Thank you. Thanks for coming, all 6 of you. When I was scheduled for Saturday, I was pretty sure I'd be given the death slot. It's not like in TV slots, like 11 o'clock on Tuesday night, and no one's going to watch that show. So, how many of you are local?
By local, what do you mean?
Like, you didn't come from out of state.
Oh, okay.
Okay. That actually surprises me, because I figured if you would come from out of state, you'd have to be here on Saturday. But if you were local, you'd be out mowing your grass or something. So, anyway, thanks for coming. Yeah, so I'm Dobry. Let me just start off with a quick little introduction about myself. So, I do some things that are not as nerdy as programming. I like the outdoors, so I use Javascript. Fun facts, regression, it's my daughter, she's pretty cute, so I always put a picture of her in. So for work, I work at Lendial. It's a company in South Jordan. It's a marketplace for small business loans, so it's a financial services company. We're basically the middleman between small business owners who need money and lending institutions that have money. So we're basically rocking the small business loan world right now. So our stack is, we got Node and a lot of PHP, MySQL, and a lot of front-end stuff. Very massive either app. The last 7 months, my responsibilities there have been primarily data science and machine learning, building some really smart predictive systems. Basically, we want to know better than our partners who they're going to give money to. I'm heavily involved in open source. I have a number of projects on GitHub, several of which are quite popular. You might have, if you use Angular, you might have seen Angular Cache at some point. I speak periodically at meetups and at conferences in Utah. I like speaking, so I think it's fun. And I have a couple side projects. One of the big ones is trading.io. It's kind of like Stack Overflow meets Codecad. So why am I going to talk about JStata? First off, JStata solves a problem that, in a general way, that will help very many developers. It basically is a data layer. So I don't know if you're familiar with Ember. There's this project, Ember Data. I don't know if you've ever used it or tried to use it. If you use Angular, then you know that it doesn't come with a data layer. It just doesn't. I mean, it has an HTTP service, but that's it. And then you're looking at blog posts trying to figure out how people built a data layer for their Angular app. How do they manage their data? Backbone comes with some facilities for managing your data, but then ends up forcing you to have tons of boilerplate around it. So, in my experience, building various front-end applications that are heavy client-side JavaScript apps, you run into the problem where you've got 30 resources on your backend. You've got all the API, the RESTful APIs to support them. And then you need to be able to handle all 30 of them on your front end in a way that doesn't result in 10,000 lines of boilerplate code. So I started out by simply creating like a base service class that you could then extend. And I would just do this in my jobs, and it would solve a lot of the boilerplate problem. But even a base service can only get you so far, because then you want to deal with like caching. One of our apps at work, it stays open on their desktop for all day. Like it's just open all day. So we need to solve the problem of just keeping heavily used memory or data in memory all the time. So JStata is the Twitter bootstrap of data layers, for better or worse. So Twitter bootstrap is used by many thousands of developers, and it can get you pretty far based on your needs. A lot of times, your app might hit some very, very specific use case that Twitter bootstrap can't handle. So that kind of thing might be also the case with JStata. It will get you a long way, eliminating hundreds of lines of boilerplate code that you never need to write, and it will get you up and running really fast. But you might run into some use cases in that where it doesn't help. But I try my best to generalize as best I can. So, just a little more background. We're just going to talk about the history of writing apps in the browser, I guess. So, a while back in the Web 1.0, you had your browser, and you had views in your browser. but you weren't rendering those in your browser. You had server-side rendering. So ASPs, JSPs, Spring, struts, stuff like that. So the browser would make requests. The servers would respond to the requests. Back end, if you have like your DAO, or your data access layer, so your server accesses your data, and then your server renders the view, and then just returns the view to the browser. And the browser just has to render it. That's all it has to do. It's a slightly different model than what probably many of us are using now. And then, so back then, this was the model because for one, browsers were slow. The JavaScript execution wasn't that great. Server-side rendering was kind of the way it was done. Most of the work was done on the server. Your only really storage option, 5, 7, 10 years ago was your database. We didn't have some of those newer web technologies that we have now. So I mentioned JavaScript as an example. So Web 2.0 came about because there came this demand for dynamic content. People needed to be able to interact with web pages quickly. And the server-side model is not the best fit for that. So it changed where the browser itself could have its own controllers where it's responding to user input. And perhaps the browser has a little model on the front end. You're starting to store some of the data on the front end. Ajax, local storage appeared. So it can start making requests to the back end, but instead of requesting the view, it's requesting data, and then it's going to render the data itself. So the server responds to the request, goes to its data store, returns with the data, and then the model and the controllers can work together to get that view rendered in the browser. And then you have a couple more storage options that became available. Local storage, IndexedDB, WebSQL. Now you have like backends as a service that are getting really popular, like Firebase, different services that can store your data for you and almost eliminate the need for that backend. So browsers have gotten really fast. The competition among JavaScript engines has gotten like V8 very good at optimizing your JavaScript and being able to execute really fast. So client-side apps are more feasible. And when you're offloading work to your clients, it's like you're distributing your work. So you've got one server, but potentially tens of thousands of users. You can distribute the work of rendering across all 10,000s of them. So it can lighten the workload on your server quite a bit. So we're going to move into how JStata plays into this. Notice here that in the Web 2.0 model, you kind of have two models, or data layers. One on the back end that's accessing your persistent storage database, and one on the front end that's accessing maybe shorter term storage, local storage, or maybe you don't even have a back end, and your front end is just communicating directly with some back end as a service, parse, Firebase, something. So with the whole Web 2.0 thing, many dozens and dozens of frameworks have appeared, and you've probably used some of these. Just to get a little feel for my audience, how many of you have just started programming in like the last 6 months? Okay, no one. So 1 to 5 years. More than 5 plus. That's awesome. So for how many of you have spent more than 5 years working with JavaScript? Less than 5 years? That's the rest of you. Cool. So maybe some of you actually have some of these frameworks. So lots and lots and lots of frameworks. Each one of these frameworks comes with its own conventions and its own philosophies and opinions on how things should be done. Some of them come with a data layer, facilities for retrieving data from your server. Some of them actually have ways of managing that data in the browser for you in a cohesive, understandable manner. I mentioned Angular or Ember data earlier. Angular, nothing, doesn't really have anything for you. React, there are patterns that they've talked about that really do things for you there. Anyway, they're all very different. But the use case is that every app is going to need a data layer, pretty much. Most of your apps are CRUD, meaning you're doing CRUD operations. You're creating themes, you're updating things, deleting things, making lots of reads. So it's such a common use case that it just seemed like there was a piece missing that is missing from many of the frameworks. When you're changing frameworks, a lot of times you got to rewrite the whole data layer because your new framework is doing it totally differently. With JStata, it becomes a framework agnostic data layer that you can just leave in place, switch from Ember to Angular, you switch from Angular to React, you just leave it there, and it still works. It works with both frameworks. So, in this model with JStata, there's the whole Web 2.0 request data from the back end, get data back, render it. What is this model going to be on the front end and on the back end? So this is where JStata can come in. It runs on the browser and on the server, so if your back end is Node, then this applies to you. If it's not Node, then it doesn't. But if your back end is Node, JStata can be your ORM on your front end and your back end. So in somewhat of an isomorphic manner, you can be writing code using the same API on the front end and on the back end to work with your data. So the way JStata works is the core of it is an in-memory data store. It resides in memory. It uses identity mapping to reduce the memory footprint of your app. Once an item has been injected into the store or loaded into the store, it will remain unique, and any reference to that item remains valid throughout the lifecycle of your app. So if you were to load the data again, it will just be merged with the existing item, and you can just keep references to your data, and it doesn't throw data away or make copies or anything like that. So, and then the way it talks to your various persistence layers is through adapters. So regardless of whether you're trying to talk to a RESTful backend or IndexedDB or local storage or Firebase, you're going to use the same API. You just tell it which adapter to use. And the adapters that extract away from your code the particulars of the persistence layer that you're trying to talk to. On the server, there are a bunch of adapters for various databases. A bunch of SQL databases, Mongo, I think. So it uses adapters. So this is what has kind of come from this project. I don't know if any of you are familiar with readme.io. It's really sweet for the documentation. So, this is the website for JStata. So far, I've been the primary contributor, but I'm definitely looking for anyone who wants to help in this kind of project. So maybe you can come be a part of, or maybe if you're heavy into like Mongo, then maybe you want to take responsibility for the Mongo adapters. So the driving philosophies behind JStata. So first and foremost, I want it to be easy. I want you to be able to just drop it in and then immediately start talking to whatever persistence layer you have, storage, your database. So it gets you up and running really fast. Go ahead.
So forgive me, I'm probably a little slow here. So JStata is something that you're making?
Yes.
Very cool.
So maybe this is like perhaps like maybe a pet project presentation, but right now it's used by hundreds of developers and they kind of are foaming at the mouth. So I'm just trying to get the word out because honestly, a Twitter bootstrap for data layers is just something I think can help many thousands of developers. A lot of times you have like a sweet idea for a side project that you want to prototype really quickly, and I know part of the purpose of side projects is so you can just learn new technologies and kind of hone your skills, but other times you just want to get the idea shipped. And so a tool like this can get you up and running really fast. You don't have to worry about your data. It just is going to start working for you. You can worry about the other particulars of your app that are unique to your side project that you can spend your time on. So
this prevents you from having to get your data like from REST services or something like that.
It will help you with that, yeah. So one of the primary benefits is how much boilerplate code it will eliminate from your application. And it's quite amazing on that front. So continuing with the philosophies, a recognizable API. I pulled the API from, if you've used tools like Mongoose or various things like that, you'll kind of recognize that it's trying to do an update or a find or whatever. So what you mentioned, like hitting your RESTful API, it makes some assumptions about your RESTful API. I know there isn't really a single standard that people follow when it comes to what REST means, but it's highly customizable. So while it does make assumptions, you can pretty much customize everything about how it's going to build the URL or where it's going to find your data or what kind of format it sends or receives the data from your API. So it makes your code simpler. It's framework agnostic. If you're the guy who likes to continually rewrite your app and new frameworks, this is one of the parts where you're not going to have to rewrite it. You can just keep your data layer the same, and your framework is like you're swapping out the controllers and view parts of your app in this model layer, so you can use stay the same. It's also storage agnostic because of the whole adapter model. So regardless of what database or systems that you're trying to talk to, you should be using the same API and just swapping out adapters. You're trying to use multiple adapters to manage like an offline seeking app or something like that. So like I mentioned, it makes some assumptions. There are conventions it comes with, but then it's highly configurable. So you can tweak almost every piece of the library and to meet the needs of your data. And then I tried to code defensively. So there's this design my contract that I follow. So the entire API it has expectations when you're going to call a method on what kind of arguments and types, and so it will try and be helpful if you're doing something wrong. Try and let you know what the problem is so you can fix it. Kind of like how React does, I like that. So, let's go through some examples real quick. That creates a new data store. You have one. Is that readable? Is that big enough? Okay, good. So you have data store, and it creates the in-memory part of the store, whether you're running on the front end or the back end. So this adds an HTTP adapter to the store. So at this point, with two expressions or statements that have been executed, there are dozens of assumptions that are being made by the data store at this point that you can immediately start working with your data. And it can start hitting your RESTful endpoints with this HTTP adapter, which is how that would work right there. Right here, I added in a Firebase adapter. So now you can be hitting either your RESTful endpoints or Firebase, and then you're going to be using the same API regardless of which one you're using. Go ahead.
Is it going to be using both?
It can. Yeah. So, go ahead. So, it's partially up to you. Hopefully you know where your data is. It might be that your back end manages like 27 of your resources, and then for some reason you decided that it would be easier if like 3 of them played Firebase. So for different resources, you can have them be using different adapters. Another option is if you're going to use multiple adapters in tandem with a single resource, that would be in like an offline type application where primarily your data is stored on the back end, but if you like lose connectivity, after you loaded it from the back end, you then put it in local storage or IndexedDB, and then you go offline and you can just be working with IndexedDB. As far as how to merge your data once you come back online, it doesn't do that yet. So that would be something you would have to manage. It depends on your data, I guess. So you can set default adapters, like in this example, the HTTP adapter is the default. But during any method call, you can say, you know what, use Firebase instead for this call, and then do something like that. So, with the memory store in place, it's now time to tell it about your various resources. So you just grab the store and you say define resource. You give it a name. And once it has the name of the resource, it makes all these assumptions about what kind of endpoints it's building for your URLs and things like that, all of which is configurable. But this is the simplest definition possible. After it's making a bunch of assumptions. So the memory store knows about the district resource. That's a typo, I should say define resource there. So store define resource school, so now I have districts and schools, 2 different resources. Never did catch that typo, sorry. Notice in this second definition, I have a little bit more meta information about the resource. In this case, it's defining a relation. So it's saying that schools belong to districts. Right here, this syntax right here, it's saying schools are going to have a local key called district ID, and that is going to be what points to districts. And then JStata is capable of linking your relations together for you. So a school and a district, if the district of a school is injected into the store as well, the school will be given a reference to its district. And then local field, that will be the property on the school that will reference its district. So whether it's a has one or has many or belongs to relations, JStata will automatically link all your data together, and they'll just have links to each other. In 2.0 of JStata, which is coming up soon, it uses the new getter syntax. It's not that new, but it uses the getter syntax, and so your references to your relations will be always up to date. They will just transparently be linked for you. You never have to worry about it. It's pretty cool. So I'm going to talk a little bit about some of the default assumptions that the data store makes from those simple definitions. For example, if I have a resource which is called district, and I didn't configure anything else about it, it's going to assume the primary key for district is ID, which you can change that to _ ID if you're Mongo. Yes, that's what they like. It's going to assume that get, post, get, and delete on /district, additionally having that dynamic segment of the primary key. Those would be like the RESTful endpoints for your CRUD operations. You can configure everything. Do you need a base path? Do you need a suffix? Do you need to change the actual endpoint? So it's different from the name of the resource. All that stuff is configurable. For the belongs to relations, you can say that for like school belongs to district, you can say district is also parent, so that in the URL, some people build their APIs where you would have like /district, /ID, /school ID. Some people nest their URLs like that, so you can have the URL built that way. So when you instantiate a store, it comes with a slew of default settings. When you define a resource with the store inherits these store's default settings. So you can override settings on a resource-based level. So at that granularity, you can override default data store settings. Also, when you're calling methods, you can override options during the method call. So you've got like 3 levels of specificity on all of your settings, and it's just automatic. So you got default settings, resource level settings, and then settings during the method call itself. You can override anything at any point. So the API has 2 parts. There's a synchronous part to the API and an asynchronous part. This is to help you. The async part is to help you with communication and interaction with your persistence layers. The synchronous part of the API is interaction with what's already in the store. So this is a little example. So I'm going to grab my district resource and call get, which is like find, except it's synchronous. It's say, look at my store and give me the item, give me the district that has an ID of 1. And there's nothing in the store yet, so it just returns undefined synchronously immediately. It returns undefined. So since it's not in the store, I'm going to go find it. HTTP was my default adapter, so what that's going to do is it's going to make that GET request on the endpoint using the HTTP adapter, which responds, or the call to find immediately returns with a promise. So promises. That's how it handles asynchronous operations. So it returns with a promise immediately, but then after some latency, your backend responds with the district with some JSON, which resolves the promise, and then the district is injected into the store. So the promise resolves with whatever item you're trying to find, and then down here where I do district.get, it's that same synchronous operation that I performed at the very beginning, except this time it actually returns with what's in the store already. And notice that this district that the promise resolved with, and then the return value of get, they're strictly equal because it's the same item. It just returns what is in the store already for you. So what that means is you're not dealing with copies of data. You're dealing with actual references to the item in the store. And it uses identity mapping to keep the same item in the store. So if I were to call find again and get the same object back from the back end, that result will be merged with what's in the store. And then any reference to that item you had previous to that second find would remain valid. You'd still be pointing to the same item. Go ahead.
What do you mean by merge?
Mixed together. Yeah, so
All the individual documents are just put in a collection or a list, or the actual documents will merge together?
the actual documents are merged together recursively. And the second one waits. Last one waits. Go ahead.
Walk through what's happening in that function.
In which one?
In the event logs. So I see the get equally district, but why do you don't return district find?
So this talks about how since the district was not in the store yet, so when I made this first find call, it made an HTTP request.
Yeah.
I make the second find call, and it's like, hey, it's already in the
It's
store.
cached, okay.
So no find request.
So
no HTTP.
why do you need to call that?
No, it's just for the example to show
Oh,
the cache. It's just to
okay.
show the caching capabilities. So
Okay, so
this promise, because this returns a promise, this is going to resolve immediately.
Oh, okay.
Just immediately resolve. Yeah. And there are options you can pass. You can say force a new request if you like want to force getting new data to the server.
So why do you have to make this head call with SQL get?
This one right here,
Uh-huh.
this is just for the example to show that the result of this
Only the
is
result.
strictly equal to this. This is all contract.
Just to show us that
Just
they're
to show
strictly
you
equal.
the capability, yeah. So once again, notice that this find just resolves immediately because the district we already loaded it. So there's the caching part of the store. And then once again, it's strictly equal. So this is strictly equal to the result of this, which is strictly equal to this. It's the same item, still. So this is going to be an example of actually saving data. So it's kind of the same, similar example, except this time we're saving data. So our district is already in the store from our previous example. So get will just return with it immediately. One thing about JStata is it has its own internal change detection, and it doesn't force you to use setters like Backbone does. So in Backbone, you have to use a setter in order to get that change event fired, so you can like react to changes to your data. This is using Object Observe or Polyfill to watch for data changes for you, and you can react to changes even if you just use the dot operator to modify a property on your object. So you can use setters, but you don't have to.
So if the district doesn't change, then the state is unlocked.
Sure. Yep. Yep. So
If I use the dot modifier like that, is it going to be saving it all the way back to the persistence there? Or do I then have to call dot save?
dot save right here. Yeah. So there's modifying what's in memory, and then there's persisting that.
Okay.
Right? So this modifies the object in memory. This is going to persist it.
Okay.
So in Backbone, the only way to do this is you got to use a setter, right? So here you just use the operator. Yeah. So we're going to call save. That's going to do put, or if you think it should do a patch, you can override that. Basically, server responds with the updated item, which then is merged into the store, and you have the latest data in your store. Back to this promise. So once again, it's strictly equal. It's still the same item. Nothing was thrown away, nothing was lost. We got the latest data from our server, and then the internal cache of the store is updated with the latest data. So right here, I'm going to destroy that item, which does the delete. Or if you think that should be a get, then sure, don't know why. But there's an example of the life cycle of the item, or of one of your resources. So CRUD apps become very simple when you're just doing save, find, destroy. It's very easy. It manages your data for you in the cache. For example, with Angular, you have the resolve part of your routes before you want to load controllers. In your resolves, you put your finds and your find alls. You get your controllers, and the data has already been loaded for you. You go back to the view again, and those finds just resolve immediately to the cache data, and it's easy. So here's a comparison, or I guess the counterparts of the synchronous and asynchronous methods. So synchronous ones, they interact with what's already in the store. These are asynchronous because they're going to be delegating their work to adapters, to your RESTful API, IndexedDB, Firebase. Yeah, should make sense. Go ahead.
How are you normalizing Mongo with relations versus SQL relations? How are you?
So the adapter abstracts that away from you. In the Mongo adapter, it does it all in the application layer, right? So it loads the data, hooks them together, returns it to you. In the SQL adapter, it knows how to do joins and things like that. Yeah. So each adapter will try and take advantage of the capabilities of its persistence layer as best as possible. So one of the cool parts here is this filter and this find all. So find all those are the collection-based methods. So this is like doing a GET request, slash resource name slash an ID. This one's just slash resource name because I'm going to get an array of objects back. Now, your APIs probably have some syntax that they understand as far as how to define criteria, as far as what to return, or if I need to skip, or if I need to limit, or offset, things like that. So JSData's filter, the internal one that can filter what's in the data store, it has a query syntax that it understands. So you have two options here. You can either teach your server to understand the same query syntax, and that way you can write with your client side a query that will pull data all the way from your data store or your database using this query syntax. Your other option is to override the code in this filter to understand the query syntax that your server already knows. So you pick which one, you teach it how to talk to each other, and then in your JavaScript in the front end, you can say, give me all the users where age is greater than 30, limit 10, offset 50, so let's say you're getting age 6 or something, right? And then you write that query, and if your server can understand it, it comes back with the data. Or if your server already understands a different query language, which is something that would work, or PHP has its own way of doing it. So we overrode the logic here, and then told it how to understand or use a different query syntax, and then that works. So go ahead. Oh, Cam.
What is like the default assumptions for query syntax?
So it's kind of similar to the Mongoose query syntax, kind of similar. Except less dollar signs and things like that. I can pull it up real quick. Let me just kind of show you what it looks like. Let's see. Query syntax. So. Is that readable? Okay. So whether you're doing find dollar filter, this is the default query syntax that it understands. So for example, this is saying get all the comments in my data store where the user ID is 5 or something like that. So basically you have your where clause, which selects fields and then applies operators to them. You can either and or those together. And then this is just an easy shorthand if you're doing a very simple quality check on things. And then there are more operators, not equals, strictly not equals, greater than equals, a bunch of operators. In, not in. So this is in the documentation. There's also order by, if you want to sort stuff as you retrieve from your data store. There's paging, offset, and everything. So does that answer your question?
Yeah, that's great.
So you can either teach your backend to understand this, or you can override all of this with something your backend already understands. Go ahead.
So how long did it take you to write the conversion between all these queries into the, I'm assuming, in-memory loop?
So for like the backend adapters?
Just yours for the in-memory one. It looks really nice. I'm just curious how long it took to write that.
Really not that long. Probably the longest time was just trying to reduce boilerplate on the actual code itself. It's not really functionality, just trying to make it look nice. So it actually is like this big now, so it's pretty nice. So all of the adapters, if you're going to be using JStata on the server, they all understand this query syntax, so you don't have to worry about that. They just natively understand each other. So, but if your backend is PHP, like ours is, and it has its own way of doing things with its ORM framework, then we just decided to just teach our front-end data layer how to understand that. Go ahead.
The actual wire layer, we're going from the front end to back end that understands that. You just realize an actual JSON query.
Mm-hmm. So when, for example, if you were to call find all instead of filter here, and it's passing in this data right here, then all that gets serialized to a query string. So it's like a JSON object that gets serialized, and then on the back end you just parse it. And if you're using the adapter, you just pass it straight to the adapter, and the adapter already knows how to use it. If you have a different backend, then like I was saying, you got to teach one of the other how to know what it means. For one app, I just wrote this express middleware that can take this query and just on the fly it translates it to what the backend understands, which actually looks that different. Anyway, it just depends on your use case or which one you want to work on, things like that. Any other questions?
So how do you handle error conditions?
So like if a find all fails,
Yeah.
so in the promise,
You do the reject.
you got .then for a success, and then you got .catch, or you can have an error handler for the error case. So if it errors, obviously nothing's going to be injected into the store. That would just be up to how your front end wants to handle that. You know, display an alert or whatever. So yeah, so all the promises they resolve or they reject based on the error case. Before I do demos and examples, I'm going to talk about a few more features. And we can have some more questions. So there are model lifecycle hooks. So if you've used anything like Mongoose or SQLize or other ORMs, they a lot of times will provide you with hooks that you can plug code into the various lifecycle steps of any given resource. So for example, if you just want to save something, it seems like a single operation, but if you have multiple steps in that lifecycle, then you got like before validate, validate, after validate, before save, save, which is the actual save, and then after save. So you can plug into all these different lifecycle hooks in the data store. So if, for example, after you save something, you want to just always do this one little piece of logic, you just stick it right there in the lifecycle hook. Or if you want to add your own schema validation, you just stick it in the validate hook. Like that. So lots of lifecycle hooks. A lot of times I'll use like the after inject hook to emit some event, and then something responds to that, or is listening to that event, things like that. It has relations, like I was talking about. Belongs to, has many, has one. It links your items together based on the relations that you define. So your items will just have references to their relations. You don't have to call methods to get their relations. You just use the dot operator. You just get them directly. And then it will be smarter about cyclic JSON when you're trying to save things, and you can avoid that. So like I was saying, in 2.0, I'll use the JavaScript getter, define property getter syntax, so they'll be non-enumerable, so you don't even have to worry about that kind of stuff. And then you can load relations for like side loading. If you loaded a user and then you want to load its organization, you can call load relations on the user and it will load its relations. Whichever ones you define, it's just an option that you have. So when you're defining a resource, you can add static methods. So it's like a resource, it's like a class. So static methods on the class, or this singleton, allow you to add various logic around your data layer. So frequently on my user resource, I'll add a method like get me the logged in user. You know, it's just like a standard logic you have on your resource. Or the log out method, or login method. Just different things. You can either define your static methods below like this after you've defined the new resource, or you can just put them in here as properties. You can also define instance methods. So for those instances of your class, you can give those instances behavior. So these methods will go on this prototype. So some people prefer to have really Pojo-like instances that can't do anything and aren't that smart, and then they use their static class to do all the logic. Some people like to put all their stuff right on the instance itself, so it's very convenient. They don't have to like inject the class just because they need to do some operation. They can just call the method on the instance. Depends on your style. I will say, however, that all of the find, update, save methods that I was showing you, those methods are on the data store. They're on the resources themselves, and then they're shorthanded on the instances. So if you have an instance, you can call save on it, and it will just save itself. If you have the resource, you can call save, and you pass it the ID of the instance you want to save. If you have the store and you don't have the resource, you can call save on the store, and then you just got to tell which resource and which ID. So shorthands of the wazoo, I guess. Oh, I had a slide on that. So this is what I was talking about. These all do the same thing. It's just depending on which, do you have the store injected in this various part of your app, or if you just only have the instance and you don't have the resource or whatever. They're just shorthands, they're all different. Computed properties. So thanks to the internal change detection, you're changing properties on your items using just the dot operator. Those computed properties get recomputed for you. So this looks familiar if you know Angular's dependency injection. So I depend on the first and last properties. So when they change, I need to recompute using this function. It's invoked in the context of the item, but these will also be passed in as arguments. So you can just use the properties. So we kind of mentioned querying collections. We kind of already went through that. So I inject a bunch of users into the store. I say, give me everyone who's older than 18. It's going to just return me this guy. He's the only one older than 18. Yeah, so you can add schema as a validation in 1.x. In 2.0, that's been removed, so you can use whatever validation you like. It's not coupled with any particular validation library. The change detection, so it actually tracks the changes for you. So you can actually inject an item, change it, and then get a diff on how it's changed. So you know what kind of fields are removed, added, changed, or whatever. There's also a setting where you can keep like a running history of its changes as like entries in like a history, and then you can like play it back in case if you want to. So you can ask an item, have you changed? And it can tell you yes or no. Different things like that. It has some cache expiration capabilities, meaning, okay, I injected some stuff into my store, but I suspect it might get stale after 30 seconds or 15 minutes. So after 15 minutes, I want you to, in this case, eject it from the store, just pop it out. And so then if it gets requested again, it'll just get pulled from the server fresh. There are other actions you can do here. You could say, don't do anything, which that's how you turn it off. Or you could say, automatically refresh it for me. So just make your request for the latest data for you, or just re-inject it into the store. Just ignore that it got stale and just put it back in, make it fresh. Oh yeah, so I guess it's the end. Thank you. I was going to go through some more demos and examples. Do you want to do that? Yeah. Okay. Some of the links. There we go. So this demo is incredibly simple. It's the same demo. One of them's in React, one of them is using Angular. So, and forgive my React because I'm not as fluent in React, so it might not be the same. But notice how both of these demos, they have the same data. That's because in this particular example, I'm using the Firebase adapter, and both of these demos are pointing to the same Firebase. So if you actually were to manage to get to this URL, you can come in here and say, add a guy. Boom. And then I didn't add in the, what do you call it? Like the three-way binding to the Firebase adapter yet. So on this other tab, I refresh it, and there's Aaron. But what I do on my other apps is, for example, on my back end, I'm saving data, and then my lifecycle looks like the after update hook. What I do is I have WebSockets that like emit some message to all my clients that are connected, and they all get this message that say, hey, this item with this ID, it just got updated. And then all of those clients, they can say, hey, it just got updated. That's relevant to what I'm looking at right now, so I'm going to go get that and get the latest view, and then you can get like this three-way data binding across all of your browsers. And we have that implemented at work. It's pretty cool. So one browser guy changes something, all the other browsers, they just get the update. And that's not using Firebase. It's just kind of it's an easy avenue with those lifecycle hooks and events where you can just implement that sort of binding. So in the demo, hopefully that's readable. In the Angular one, it's pretty simple. I depend on the JStata module. I go grab the Firebase adapter provider and tell it where my Firebase is. Down here, I register the adapter. Down here, I define a resource. A lot of times in Angular, you define a resource and put it in a service factory, which is then injectable everywhere else in your app, and that becomes your data layer. You just inject it into your controllers or the resolves for your routes or wherever, use it. Down in the controller, when the controller first loads, I just say, give me all the users. This is saying, take all my users and bind them to my scope. So whenever the collection of users changes, I'm just going to go and update what's on the scope here. And then a couple scope methods. If I'm going to create a user create, pass it to user, remove it, just destroy it. So it's a pretty simple API having create and destroy that you just use and it works.
Pretty freaking cool.
Yeah, that's what I hear a lot, and I really appreciate it, and I just want this to be able to help as many developers as possible. Maybe in your app you're building at work, it's like some very specific WebGL something, and this is not going to be really useful for you there. You probably don't want to be putting millions of items of time series data in this for performance reasons. You're going to have some custom role insertion there, or some library specifically built for that. But for pretty much any CRUD app, this is going to make your life way easier. So back to the React example, which again, forget my React. No, indeed. So there's this flux thing, I guess, right? Where apparently you have actions that like trigger events, and then based on the events, your components pull to get their latest state and re-render. So with JSdata, in this demo in particular, I went to the Flux page, the Flux architecture page on Facebook's site, and I took that demo, and I took all the actions and the store and the dispatchers, and I just replaced them with JSdata. So right here, if I'm using the Flux pattern, I guess you have a store, so I called it store, so I can build it Flux. And then what I did is I looked into those lifecycle events, and I said, you know, every time something's injected into my store, I want you to emit this event. So each resource in JSdata is an event bus that you can use. Down in my component, way down here in the component, on component did mount. There it is. So when my component mounts, I start listening to that user's change event. And then when it changes, I call on change right here, which gives me the latest users in the store. So then, because my state changed, this render function goes and re-renders my items. So, Flux. These are very, very, very simple demos. I have some larger ones that I can point you to if you wanted to go explore them and see them. There's a JSdata-examples or JSdata examples repository that is in progress. There's a JSdata organization with like 17 repositories in it, and they're just like the various adapters, JSdata itself, the examples repository. You can explore the examples repository to see kind of like an Angular app. The goal of that repository is where you can kind of plug and play backends with front ends to just play with various uses of JSdata. Another repository you can look at if you want to. This one uses React and I guess like a Flux architecture heavily. This one's on my personal GitHub. It's called Repo Pro. You can come in here and explore how these various models are in here. So like I have like these JSdata resources, like here's like the configuration that maybe looks familiar from the slides, instance methods, and then over my components themselves, you can see that like on component did mount, I'm listening for a bunch of changes on different resources. So JSdata can be like your stores and your dispatchers in like a Flux architecture. So, and then because it's framework agnostic, it doesn't depend on anything that's specific to any given framework. You can use this as Backbone, Aurelia, jQuery, or whatever else you're using. It's written in ES6, so if you like writing ES6 code, come contribute. That'd be awesome. Let's see. Were there any other hands? Any other questions? Next. So basically, your homework is to go start a new side project, load JSdata, and then just have your mind blown by how easy it is to just start working with CRUD data. I mean, it's really cool to have your REST backend, and then you just say, hey, use the Firebase adapter instead, and now you've got this entire CRUD-like API on top of Firebase, which if you've used before, you know that the API is not exactly CRUD. It's not that. So being able to use a nice simple code API like Firebase is really cool. Yeah, so I think that's it for now. If anyone wants to come talk to me after, I'll be around. So just to show this slide, I'm supposed to put this joint thing on there. I use for feedback or something. So yeah, thanks.